Administrator Dan Golden established Dryden as a full NASA center, effective March 1, 1994. This will enhance NASA's flight research program, streamline management, and better serve the aerospace community. Dryden is reaching new heights in our commitment to serve our customers, the aerospace community, and the American taxpayer. In this video, we'll take a look at recent flight research accomplishments, employee activities, and Dryden's community involvement. Proving the value of multi-axis thrust vectoring for highly maneuverable aircraft has been a dominant theme of our flight activities. The X-31 International Test Organization had quite a string of successes with the two thrust-vectored aircraft. The X-31 is the world's first to demonstrate a J-turn, or Erbst maneuver. The Erbst maneuver, named for the late German pilot and engineer Wolfgang Erbst, consists of using the thrust vectoring system to pitch the X-31 to a 70-degree angle of attack, then rolling 180 degrees about the velocity vector. This results in a very high turn rate and is a definite advantage of post-stall maneuvering. The X-31 team broke an experimental aircraft annual test record with 160 flights. Team members developed and tested helmet-mounted displays to assist the pilot in performing high angle of attack maneuvers. The tactical improvements provided by the suite of X-31 technologies were evaluated during multiple aircraft maneuvering tests. An Aviation Week magazine's annual Laurels Award was presented to the X-31 team leaders for significant aeronautics and propulsion accomplishments demonstrated on the X-31 aircraft. Research with the F-18 HARV, High Alpha Research Vehicle, is entering a new phase. NASA Lewis, Dryden, and General Electric researchers developed an inexpensive engine inlet brake to measure inlet disturbances during high angle of attack flight. This rake recently provided unique inlet pressure distributions for engine stalls occurring at extreme attitudes and rates. At angles of attack in the 80 to 100 degree range, 15 self-recovering stalls occurred. This data is currently being analyzed by NASA and industry groups. Another system being designed and built by NASA Langley is an actuated nose strake for enhanced rolling system, ANSWER. This system, to be installed and tested in 1994, manipulates the four-body vortices shed during high angle of attack flight and imparts yawing moments on the aircraft. Active closed-loop control of the strake will enable yaw control of the aircraft in angle of attack regimes that have reduced rudder and aileron effectiveness. NASA researchers are helping Pratt & Whitney, McDonnell Douglas, and the U.S. Air Force develop an axisymmetric thrust vectoring system. The F-15 Active, for Advanced Control Technology for Integrated Vehicles Research Aircraft, will test this technology in early 1995. Integrated control of advanced thrust vectoring engine nozzles will increase overall engine performance and can be retrofitted to existing aircraft or used in future aircraft designs. The F-16XL aircraft continue to support NASA's high-speed research program. Laminar flow flight experiments focused on wing leading edge measurements that will improve knowledge of the leading edge fluid mechanics. Measurements establishing laminar flow sensitivities to angle of attack and Reynolds numbers were obtained. In addition, turbulence diverters which prevent fuselage turbulence from contaminating the wing laminar flow were developed and tested. 3 turbulence diverters were tested and 1 was selected for use in a joint industry-NASA laminar flow control experiment scheduled for 1995. Modifications for this large-scale supersonic laminar flow control flight experiment began in July of 1993. The SR-71 conducted flights in support of aeronautics, science, and space technology objectives. An F-16XL was used to measure the SR-71 shock wave 50 to 750 feet below the SR. These data are being used to validate sonic boom prediction techniques and to help aircraft designers understand and soften sonic booms of future high-speed aircraft. Other tests for the SR-71 included an optical air data measurement system. The The aircraft was also used to simulate a low Earth orbit satellite to receive and transmit iridium cellular communication signals for the Motorola Corporation. The SR-71 served as a platform for a JPL experiment to obtain ultraviolet backscatter measurements in the Earth's atmosphere. These measurements will enhance man's understanding of the Earth's heat balance. Flight research in the F-18 Systems Research Aircraft, SRA, included evaluations of electrically powered actuators and fiber optic control systems integration. NASA and the Air Force have developed and are testing 3 types of new technology actuators: smart hydraulic, electromechanical, and electrohydrostatic. To date, a smart hydraulic actuator implemented with fiber optic flight control computer links has undergone extensive flight evaluations on the SRA. These evaluations have proven that localized electronic control of an actuator is practical in modern aircraft. Localized actuator control will provide many benefits: reduce wire count, reduce weight, and increase reliability. Fiber optic system integration testing on the SRA is being conducted as part of NASA's Fly-by-Light, Power-by-Wire program. Working with NASA's Lewis Research Center, numerous fiber optic aircraft control position and engine performance sensors have been integrated into the SRA. Flight evaluations are revealing improved methods of integration are necessary before fiber optics weight savings can be commercially achieved. NASA Dryden and McDonnell Douglas researchers are developing a system to control an aircraft using engine thrust as the only control effector. Software enhancements in the F-15's flight and engine control computers enable the pilot to control the plane using only engine thrust. The world's first successful landing without using any control surfaces was accomplished April 21, 1993. McDonnell Douglas is expanding propulsion-only landing technology in piloted real-time simulations, developing a system for an MD-11 aircraft demonstration. In support of the country's pursuit of high-altitude atmospheric sampling capabilities, the Perseus high-altitude platform aircraft made its maiden voyage December 21st at Dryden. Aurora Flight Sciences Corporation designed and built Perseus and conducts the flight test program. The remotely piloted research aircraft is designed to gather data from the upper atmosphere. Following an intensive flight development program, Perseus will gather data between 65,000 and 82,000 feet, bridging a gap between measurements from NASA's piloted research aircraft and space-based instruments. It will also help scientists better understand Earth's atmosphere and aid in the design of aircraft and engines which are environmentally compatible. NASA Dryden also supported the Department of Defense Raptor Pathfinder project. It's an experimental, high-altitude, long-endurance, solar-electric unmanned aerial vehicle. The goal of the program was to fly at extremely high altitudes for weeks at a time, providing the United States with a broad range of military, civil, and commercial capabilities. Dryden's facilities, located near the dry lake bed and protected airspace, provided an ideal environment for operation of this large, fragile vehicle. The F-104 flight test fixture supported a joint UCLA-NASA experiment to understand fuel mixing at transonic and supersonic speeds in scramjet engines. A nozzle was developed that could spray iodine at transonic and supersonic speeds perpendicular to the flow around the fixture. These flows were visualized by pulsed laser-induced fluorescent beams which visualize the jet's trajectory. Data from this experiment will enable empirical correlations of CFD analysis, currently unavailable from wind tunnels because of wall interference. Dryden tested a large periscope on a Lockheed F-104 to see if pilots can rely on it to land future high-speed aircraft. Conventional windscreens are difficult to design for high-speed aircraft because of heat and drag loads, and high body attitudes on final approach make it difficult to see over the nose. A recessed or retractable bottom-mounted periscope is one solution to allow a pilot to land the aircraft without a forward window. A research external vision display was built by General Dynamics and Kaiser Electro Optics for testing on the F-104. The flight evaluations showed that although the system had slightly different color and experienced substantial airframe vibration, if the system had a minimum of 30 degrees field of view, no information was lost necessary for landing the aircraft from steep and shallow approaches. A landing systems research aircraft has been developed by Dryden under the sponsorship of the Space Shuttle program to improve understanding of space shuttle landing limitations. A Convair CB-990 aircraft has been modified to land on its own gear, then hydraulically lower a space shuttle test wheel and tire to the runway at the high loads and slip angles that an orbiter would experience in a strong crosswind. The resulting side and drag forces and critical tire wear were measured. Data are being used to update simulations and establish the largest possible crosswind landing limits for the shuttle. Space Shuttle Columbia, STS-58, landed at Edwards November 1st, 1993. We opened the gates at Dryden for this stop, the last scheduled space shuttle landing here. Approximately 15,000 people lined the hillsides and the NASA flight line to view STS-58 Columbia's return to Earth. Bad weather conditions at Kennedy also forced STS-59 Endeavour to land at Edwards April 20th, 1994. Facility achievements at Dryden were highlighted by the Integrated Test Facility, ITF, completing its first year of operation, providing advanced X-31, F-18, and F-16XL ground-based simulators. In addition, the ITF team has tied actual aircraft flight hardware with ground-based electronics. Resulting simulations have significantly reduced ground checkout time for advanced control systems development and reduced troubleshooting times for systems anomalies. Testing techniques developed within the ITF have been widely distributed within industry and government. Dryden's Western Aeronautical Test Range supported 356 research flights and 54 ground tests in preparation for flights in 1993. The Western Aeronautical Test Range Group supported this record research flight rate while providing 29 days of support tracking space shuttle flights. In addition, the group extended its data link capabilities to other tracking stations and satellites to be able to support the extreme ranges covered by the SR-71 aircraft and to provide real-time data for displays at other NASA centers. In the thermostructural lab, researchers are looking for new materials and structural concepts for future hypersonic aircraft. Tests include a new carbon-carbon control surface, a 2x2 titanium matrix composite, TMC, wing panel, and a 4x4 TMC fuselage panel. The 4x4 TMC panel represents a new, unique test capability of applying combined axial and shear load to over 1,000 degrees Fahrenheit. Approximately 20,000 people toured the Dryden facility last year. Guests viewed a videotape highlighting past and present aviation projects. Then our tour guides take them on a short walk around the center. The Judy Janice Child Development Center celebrated a highly successful first year of operation at Dryden. It's a full-service child development center for infants to age 5, providing high-quality care and a developmental curriculum to prepare the child for entry into school. Dryden is also involved with higher education in the region with a number of community projects. Dryden's adopted school, the Lake Los Angeles Elementary School, receives refurbished computer systems from NASA on a long-term loan basis. Staff members also continue to go to school. Dryden representatives visit area schools and talk about the importance of staying in school, getting a good education, with emphasis on math and science. The Shadow Program gives Lake Los Angeles students the opportunity to pick a job at Dryden and then shadow that mentor around for a day. Dryden also provides special pre-algebra math tutoring at the adopted school. This not only helps the students, but gives satisfaction to the tutors as well. To ensure that Dryden achieves maximum effectiveness in the ever-changing and increasingly diverse workforce, a cultural climate and practices plan was developed and implemented. The plan was developed by 4 Equal Opportunity Advisory Committees and the Multicultural Leadership Council working with Dryden's management. The plan enables Dryden to achieve important multicultural goals. An active Disabled Employees Committee assists management to assure that equal opportunity is available for all. Committee members tour the facility to identify areas that would be a disadvantage for the handicapped. These improvements will bring Dryden into compliance with the Americans with Disabilities Act. In August 1993, NASA and the entire aviation community lost a true pioneer, Milt Thompson. He was one of the original X-15 pilots, a leader in the lifting body program which led to development of our country's space shuttle fleet. Hundreds of current and former employees, guests, friends, and family members paid their respects to Milt Thompson during a memorial service here at Dryden in August.
The flight programs you have just seen have resulted from the ideas of many people within NASA, the Department of Defense, the aerospace industry, and universities. Flight research plays an important role in the entire continuum of aeronautical research. In some cases, we're exploring entirely new flight regimes, such as maneuvering at high angle of attack. In others, we're validating computational code, such as for laminar flow. In yet others, we're maturing technology for application, such as the propulsion-controlled aircraft concept. In all cases, NASA is committed to developing new ideas and transferring technology to support this nation's competitiveness in worldwide markets, to support national security, and to assist the aviation community in operating aircraft efficiently and safely. The women and men of NASA Dryden are proud to be part of this nation's aeronautical research and development effort. I hope this video helps you understand the progress NASA is making in its aeronautical research program and the role that we at NASA Dryden are playing in this important effort.
one. Ignition, point ignition.
Gear touchdown. Nose gear touchdown.